Alright, so in this lesson we're going to be talking about linear versus nonlinear functions. And so you should have defined in your notes what linear and nonlinear functions were. We're going to get a visual. So we're going to plot the following points. I'm going to label, what do I want to go by? Yeah, we'll go by 2s. 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. All right. So we're going to plot these points. So 2 and then 1 would be halfway in between. And then 5. So we're going to go 4. 5 would be halfway between 4 and 5 and up to halfway between 2 and 4 for 3. 8, we're going to go to the 8, and we're going to go up 5, so that'd be 2, 4, and then halfway in between. And then 11, so halfway between 10 and 12, and up 7, so 2, 4, 6, and then halfway is 7. And so we have the following set of pairs, right? And so what we're looking for something to be a linear pair is for those points to form a line. And so how we can tell is we can find the slope, so the difference between the y's, right? So 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, right? So y minus y, y minus y, y minus y. So I know that my rise is 2, and then my run is going to be 2 minus 5, or 5 minus 2, which is 3, and 8 minus 5, which is 3, and 11 minus 8, which is 3. Now, you could go, okay, well, I just have to pick 2 points and I can find that. And that is true if you know it's a linear function, because we know that a linear function has a constant rate of change. And so our run is 3, and so our rate of change for this is 2/3. Now, that is true, but I have to check it for every set of points to make sure that one of these points doesn't just become an outlier and go AY somewhere. So you can't just pick just 2 points and make sure that it works. You need to check between each set of points and make sure that you end up with the same rate of change. And you need to check for both x and y values. All right, so that's an example of a linear function. So this one's linear. And so a linear makes a line. Right? Line is in the word itself. The following, this creates a curve. And so if it's a curve or it's not one straight line that goes on indefinitely, then it is nonlinear. So this is an example of a nonlinear. Our absolute value graphs where we're making V's, that's a nonlinear. Our parabolas, the U-shapes, those are nonlinear. Alright, so anything that does not make a line. So non means not. Alright? So, example 1, we want to identify whether the graph is a linear function or a nonlinear function. So I'm looking at A. It is just increasing. There is no other type, and so this is what we call linear because it is a line. B, we're decreasing and then we're increasing. And so this would be nonlinear because it's not one straight line, it's actually a curve. Therefore, it is nonlinear. It's not a line. And even though these are created from lines, they're what we call rays, there's this bend here, right? And so it's not one straight line. So this is also nonlinear. So that is the difference between linear and non-linear. We'll do tables in our next video, and I'll see you there.